Hello everyone, welcome to VR Certification. In this session, we are going to discuss class 11 chapter number 8 gravitation and exercise solutions. Clear? And in this session, you will find detailed solution of each and every question, as well as through the question you will find some key concept of a theory. Clear? So definitely you will enjoy this session. So concentrate on a screen. We are going to start. Let's ready. Now student, we are going to discuss question number 8.1, and in this question it is given to you. Answer the following. Clear? Number A part. You can shield a charge from electric forces by putting it inside a hollow conductor. Clear? So this is very clear to us. Let's suppose I am taking here a hollow conductor. So let's suppose this is a hollow conductor. I am drawing here, this is a hollow conductor. Let's suppose I am placing here a charge inside this hollow conductor. Now we know very well, if we are talking about a hollow conducting shell or hollow conducting sphere, at that time we can see electric field, this is inside this hollow conductor we have 0. Clear to you? So electric field inside this conductor we have 0. Clear? So electric field we have 0 now, but it is given, can we shield a body from gravitational influence of nearby matter by putting it inside a hollow sphere or by some other means? Clear? So let's suppose now I am saying here, let's suppose if I am placing here a M mass body. Clear? And this M mass body is actually we place here M mass body, and let's suppose we place this M mass body in a hollow sphere. Clear? Now let's suppose here we have another body having mass capital M. Clear? So now we are saying that here electrostatic force is actually, electrostatic field inside is 0. So we can say here we can protect this charge from electric forces, that is from the surrounding electric forces. Clear? But now we can say actually if we are placing this smaller mass in a hollow cylinder or hollow sphere, or you can take any body. Clear? You can say gravitational force always act. Gravitational force always act along the line of joining like this. Clear? So it means we can say here we cannot shield any body from, if we are placing that body in any object. Clear? So now we can say no, we cannot shield a body from gravitational influence of nearby matter by putting it inside a hollow sphere or by some other means. Clear? So our answer is here, that is no. Clear to everyone? Now listen carefully. Yes. Now we are going to discuss part number B, and in this part it is given to you, an astronaut inside a small spaceship orbiting around Earth cannot detect gravity. Clear? Let's suppose an astronaut, we have an astronaut is actually in a satellite. Clear? Or we can in a small spaceship, in a small spaceship astronaut is actually having some motion. Clear? But let's suppose if I am saying, if the size of that spaceship, or we can say size of the space station, now we are making it large. At the time we can say if astronaut is moving inside this spaceship, at the time we can say it can actually feel some variation in acceleration due to gravity. Clear? So definitely we can say at the time that astronaut, it may feel some, we can say some gravity. Clear to you? So a very simple conclusion we have. Yes, if size of a spaceship is very large, at the time it is a possibility that an astronaut can feel variation of acceleration due to gravity. Clear? So this is all about part number B. Now it is given in a part number C. If you compare the gravitational force on the Earth due to Sun and then due to Moon, you will find that the Sun pull is greater than that of Moon's pull. Clear? So now actually if we talk about Newton's law of gravitation between first Sun and the Earth, and second we are observing this Newton's law of gravitation between Sun, we can say Moon and Earth. Clear? So if I write here ratio, I can say gravitational force between Sun and Earth, and we can say gravitational force between Moon and Earth, this ratio is given by G m1 m2 upon r square. So I am writing here, this is ms I can say ME over, I can say distance from between sun and earth. Clear? This is RS square multiply, I can say here this is RM square divided by this is MM multiply, I can say this is mass of earth. Clear? So I can say this one and this one cancelled out. So from here we can write like this, MS over MM multiply, we can say this is RM divided by RS and this is whole square. Clear? Now you know what is mass of a sun. Clear? We can directly say this is 2 into 10 to the power 30. 2 into 10 to the power 30 kg is a mass. We can say this is solar mass. Clear? And mass of a moon, we know this is 7.3 into 10 to the power 22 kg. Clear? Now if we talk about distance between moon and earth, so distance from moon we have 3.8 into 10 to the power 8 meter. Clear? And square divided by what is distance between sun and earth, it is given to you 1.5 into 10 to the power 11 whole square. Clear to you? Now we do not need here an exact calculation. Clear? So if you do here some approximate calculation, you can say here, yes, you can say here just if we calculate power of a 10. Clear? This is 10 to the power 30, I can say this is 10 to the power 8, this one we have 10 to the power 16 and this one we have 10 to the power 22. Clear? So 16 and 8 we can say 10 to the power 24 and this one we have 10 to the power 22. It means we can say whatever value we will get, we will write here 10 to the power 2. Clear? Yes or no? Because this is 10 to the power 16, this is 24 and this one we have that is 10 to the power we can say 22. Clear? So directly we can say whatever value we will find here, this will be multiplied with 10 to the power 2. Clear? Now we can also write like this. Let's suppose I am saying this is 2 multiply, I can say let's suppose this is 4. So 4 multiply 4, 16, 16 multiply 2. I can say this is 32 divided by this is 1.5. So we can say 2.25 and it is multiplied, let's suppose 7. So 7 multiply 2.25. Clear? So from here you can calculate, you can write like this, this is 1/4 of 7. 1/4 of 7 we have 3.5 or we can say 1.75. So 1.75 plus 14, that is 15.75. So whatever we can see here, we are getting this value approximately equal to 2 into 10 to the power 2. Clear? It means we can say here that gravitational force acting between sun and earth, it is 2 into 10 to the power 2 times of gravitational force acting between moon and earth. Clear? So definitely we can say gravitational pull due to sun, it is more compared to gravitational pull due to moon. Clear? So this is all about first part of a question number C. Clear? Now it is also given here the tidal effect of moon's pull is greater than tidal effect of sun. Why? Clear? So now let us try to understand this statement. Now actually it is generally seen if we are talking about tidal effect, or we can say TIDAL. So if I am talking about this effect, I can say this is actually inversely proportional to cube of distance between two planets. Clear? So from here we can say if I am talking about, clear, if I am talking about TM, it means tidal effect due to moon and this is sun, we can write like this, this is equal to RS over, we can say RM, and this value we have cube. Clear? So definitely we can say here we have value 1.5 into 10 to the power 11 divided by, we can say this is 3.8, so 3.8 into 10 to the power 8. Clear? Whole cube. Now you can say this value we have approximately 1/2. Clear? Or you can say this is 10 to the power 3 and 10 to the power 3 multiplied power 3, it means this will become 10 to the power 27. Clear? It means directly we can say this tidal effect of this moon, it will be more compared to tidal effect of sun. Clear? So definitely we can say gravitational pull due to sun is more compared to moon, but if we are talking about tidal effect, so definitely tidal effect is more due to moon compared to sun. Clear? So this is all about this question.